The question for today is set matrix 0. So the question is, given an m into n integer matrix, if an element is 0, set its entire row and column to zeros. You must do in place. So what in place means? That you don't have to use any extra memory. This simply means no use of extra space, right? So we don't have to consume any extra memory here. So let us see how we can do this. So an example is given to us: 0 0 0 1 1 1, all 1 and 1 0. So once we encounter a 0, we convert. Once we encounter a 0, we will convert all its row and all its column to 0. That's the complete scenario. So if we convert this to 0, then let us see how we can do it intuitively. So intuitively we say that, okay, I see a 0, I will convert it to 0, right? Next is, I see a 0, I am converting the whole column into 0, right? And then I will converting the whole row into 0. So 0, right? And 0, right? Right? So I visited initially I visited 0 initially I visited sorry I just want to go through it once again. Yes, so initially I visited this 0 0, then I went to 0 1. That means initially I visited 0 0. I say, okay, it is not 0, it doesn't matter to me. Now I went to 0 1, it is not 0, it doesn't matters to me, I will do nothing. Again at 0 2 I saw 1 and I say, so it is not 0, it is not a matter of work for me. So again at 1 0 I see that it is not 0, so I move ahead and I see that here at 1 1 I got a 0. So what I will be doing, I will be converting all the rows and columns to 0, what I did initially. So what I will be doing, converting all the rows to 0 and converting all the columns to 0. So I converted rows to 0 and I'm going to convert columns to 0. So yeah, now I am done with my work. Now what I am going to do, I am going to visit the next element, that is 1 2, and I see that there is a 0 here. And what I will be doing, I will be converting the whole row and column to 0. The row is already 0, but still we will convert, and we will convert the column to 0. So mathematically, when we try to do it without using an extra space, it will fail here, right? You are getting it where it will fail. Here the algorithm will not know that initially it was 0 or not. When it visits 1 1, it converts the whole row and column to 0, and now is it visiting now it is visiting the next cell, that is 1 0, and it says that, oh, I encounter another 0 here. What I will be doing, I will be converting the whole row to 0 and whole column to 0, and which is not the correct answer. We know that the correct answer is this. So what happens here, how we will be achieving it is, we will be using a, a token or a flag. Let's say we use our flag as F, right? Or t, that cell needs to be transformed. So in that case, what happens is, suppose that we are using a transformation instead of directly converting to 0. So suppose that I'm using t for my transformation, and then so as soon as I encounter 1 1 0 at 1 1, what I am saying, I am converting the whole row and column to t, right? Except 0. In 0 I say that everything which is not 0 in this t, I will be converting it to t. So in this row, in row 1, sorry, in column 1, I saw that I converted every element except 0 to 2t, and in row also I will be doing the same thing. I will be converting every element to t except 0. So what I get after this iteration is this. Now what happens is, I have visited 1 1 and done the transformation. Now when I visit 1 2, I again say that no, it is not 0, we can move on. Then at 2 0 we see that no, it is not 0, we can move on. At 2 2 1 we see that it is not 0, we move on. At 2 2 we see that it is not 0 and we move on. Since we reach end, what we will do, we will convert all the t's to 1. We will iterate again and convert all the t's to 1. Sorry, all the t's to 0, right? And in this way I get a correct answer. And this is the correct answer, we know that, right? So let us do this thing once again so that we get a better clarification of this question. So let us go here and see that what we find in our next example. So at 0 0 we find a 0, so we will transform all the row and column to t here, right? So I'm just transforming everything to t here. I'm transforming everything to t here. So the rows are transformed to t and the columns are transformed to t. Note that in row 1 we encountered a 0 and we are not going to transform it. We are going to transform everything except 0. So now I will moving to my next cell and I am seeing that no, it is not 0. I will move forward. I am going here. I said no, it is not 0. It is not 0. I will move forward. Then I will saying yes, it is a 0. So what I will be doing, I will be converting all the row to t. It's already converted, but it will convert it again, and then I will convert all the columns to t, right? Then I will convert all the columns to t, right? Then I will be moving my row to the next element, next row. Okay, again I will resetting my column to 0 and I say that no, this is not a 0, this is not a 0, this is not a 0, and this is not a 0. So we have not encountered any 0 in row 2. Now I will move to row 3 and as you can see that we will not encounter any 0 in row 3 as well. This is t, this is 3, this is 1, this is t. So since we have come out of bound here, for both the pointers row and column, what we are going to do, we will iterate once again to it, right? And what we will be saying that convert all the t to 0, right? So it will become this. It will become 0. It will become 0. It will become 0. It will become 0. And this table also becomes 0. Right? So this is the final answer that we get, and we very well see here that no extra set, dict, matrix or anything is used, no list is used, no extra space is used here, and we have achieved our answer. So let us go and just try to solve this problem. Okay, yeah, so I have already written a code, but this uses extra element, it uses a set, right? Although the code becomes much faster, but this is the extra memory that have been used, so we will not be using this this code this time. What I will be doing, I will be using I am just clearing it up, and I will be coding it in place. I will be coding it in place as I have shown there in the dry run. So first of all, we'll start with rows and columns. So right, so once I start iterating through it, I will see that if the matrix row and column is 0 or not. So if it is 0, I will be just transforming this matrix to T. And what is the criteria of T? We want to transform it to T if matrix RC is not equal to 0. Only then we are transforming it to T, otherwise we are keeping it as 0 only. So this is the complete transformation that will happen, right? No. If matrix, sorry here, if matrix, if the cell is 0, what we are going to do, we are transforming all the rows and all the columns. Convert transform rows, all rows, yeah, all cells in rows. And the second thing will be transform all cells in calls, right? So for transforming each cell in row, I will be saying that for for calls for call in range calls, right, I am converting the complete matrix in that row to T, right? After this we can say that, right? And now for each cells in this, I am saying that for row in range rows, I want to convert all the matrix row and call to T. Again the same criteria, if matrix, okay, so here it will be call, right? And here also it will be row, right? Same thing, if it is not equal to 0, convert it, otherwise not. Now again I am going to convert and again I am going to transverse through all the rows and columns, and this time I am in search of matrix T. So if matrix R comma C is equal to T, what I will be saying that replace this by 0. Oh, I don't know what happened. So this is my code, let us run it, and it worked perfectly fine. Let us submit it. So after submission it took 9 milliseconds, and the best thing is we have not used any extra memory. So we will see that if we analyze the space complexity, it should be order of 1. Yeah, it's order of 1. So that was it, guys. And if we are allowed to use extra memory here, then we can also reduce the time complexity. So if we try to analyze time complexity here, we see that we get row, that is m into n from here, rows into column. Sorry, we get rows into columns here, and for each row and column I have to calculate row or column. So the time complexity will be m into n into m plus n. So let us see the time complexity also. So yeah, it's m into n into m plus n. It's written by mistake, but yes, this is the thing, this will be capital N, so m into n into m plus n. This is our time complexity. It can be improved, but then extra memory will be used, right? So that was it. If you like my video, please support me, and if you have doubt you can ask in the comments. Thank you, guys.